Hello, in this video we're going to build upon what we've learned about data visualization and data wrangling to make better data visualizations. And specifically, we're going to talk about some tips for effective data visualization. So let's talk a little bit about how to design effective visualizations. One of the most important rules perhaps is to try to keep things simple. Here we have a pie chart, a 3D pie chart, and pie charts tend to get a bad rep when it comes to data visualization because they can be hard to read if you're trying to visualize many categories at once. So here perhaps we're looking at expenses from a business. And some of the things here are like cutting tools, workplace materials, machinery, labor, and buildings and administration. And there's really no reason to present this data in a three-dimensional pie chart. We can keep it simple, use a bar chart, and actually still get the message across. And most importantly, make it easier for your audience to see the distinction between these categories. For example, in the pie chart, without the numbers being noted on the various pies, it would be really difficult to tell the difference between the yellow, the machinery, and orange, the labor part. But when we have it on a bar chart where we have the bars ordered by the magnitude or the proportion of the expenses that went to each of these categories, it makes it a lot easier to see the difference. We might also think about using color to draw attention. So in the first bar chart, we have the standard ggplot2 colors where we've colored by the particular category. But if the message that we want to send, for example, is about buildings and administration, we may want to use muted colors for everything else and maybe just make that red. We also want to tell a story with our visualizations, and we're going to talk a lot about that in this video. So here we have a data visualization on hires at Duke University by month, and the various lines are telling us the various years. So I'm focusing on the left-hand side first, and there we have on the x-axis the months, and the colors of the lines tell us what year the data come from. Suppose that the story we want to tell is that hires tend to peak in July, which is when Duke's fiscal year starts. And that oftentimes with academic positions in the United States, at least, hires tend to happen starting in July. So the years don't really matter here. So using color to distinguish between the years may not be all that interesting. We may want to make all of those lines the same color and then actually annotate our plot to see, hey, here's a peak we're seeing for all of these years, and we're not interested in making a distinction between them, but just to say that hires peak here. And we can think about annotating our plot this way. So we're going to talk about some principles for effective data visualization and work through a case study to actually apply these principles. These 5 principles are: order matters, put long categories on the y-axis, keep scales consistent, select meaningful colors, and use meaningful and non-redundant labels. The data that we're going to be working with comes from YouGov, which does a lot of surveys, and this data comes from September 2019, where 1,639 Great Britain adults were asked the following question. In hindsight, do you think Britain was right or wrong to vote to leave the EU? And the options were right to leave, wrong to leave, and don't know. So we have a third option as well. And on the right-hand side here, we have a very standard visualization of this categorical variable where we can see the bars, and the heights of those bars basically indicate how many people selected that category for the answer in this survey. The first thing is that order matters. So alphabetical order is usually what you will see in your visualizations, especially if you're making them with ggplot2, but most often for other software or using other systems in R as well. But what we might actually, so this is a standard ggplot with where we have on the x-axis the opinion category, and we've just used geom bar as the geom object to create it. We may want to order by frequency. So here we have started with the most frequent, which is wrong, and then right, and then don't know, as opposed to going the other way around. How did we accomplish this? We didn't actually do this so much manually, but we used a function from the forcats package. Remember that the forcats package is useful for working with reordering or doing things with the levels of a categorical, or in other words, a factor variable. So here I've wrapped the opinion variable in the function called FCT. That's how I know it comes from the forcats package, underscore infrec, so in frequency, which will reorder factors levels by frequency. With only 3 levels, we could have thought about doing this manually, but this is a useful function, especially when you have many more levels, or when you haven't actually done the counting yourself and you just want to rely on it to do the ordering for you. We might also want to clean up the labels. So let me go back to the original plot. What ggplot2 will do by default is on the axis labels, we'll put whatever is passed to the specific aesthetic mapping. So here in the aesthetic mapping, we were saying we want to wrap the opinion variable in the FCT infrec function. And so what ggplot does is it takes that character string and just places it on the x-axis, but that's rarely what we want to show. We really just want to say that's the opinion variable. So we know how to clean up labels by now, hopefully. We use the labs function as a separate layer in ggplot to give an X label and a Y label. I tend to redo the labels like count, even though it's exactly what ggplot2 was giving me. But when I'm labeling my plots, I like using title case. So that's the first letter is capital. So I like matching them. So I've done that here as well. So the plot looks something like this here. Okay, what else can we do? Let's take a look at another variable in this survey. So in addition to asking this question about people's opinions on Brexit, the survey also collected data on the region where the respondent was responding from. So the various regions are London, Midlands and Wales, North, rest of South, and Scotland. And here are the category labels in the raw data set that we have. And they're once again ordered in alphabetical order, and geographically they're kind of all over the place. So what we might want to do is instead of using the alphabetical order, if there's an inherent level order that we might think about, we might want to enforce that on our visualization. The inherent level ordering here that I have referred to is how YouGov, the survey agency, had actually presented the data. So in their summary tables, the order in which these are presented are London and then rest of South, Midlands and Wales, North and Scotland. So since this is how they tend to present their data, I said I'm going to stick with that as well. So I want to manually order these levels in this particular order. And in order to do that, I use another function from the forcats package. This time it's factor relevel, which allows you to reorder factor levels using a custom order that you provide. So this function takes as its first argument the variable that you want to relevel, and then it takes as many arguments as you need, however many levels you want to reorder. And remember, the important thing is that the spelling of these matches exactly what's in your data set, because it's going to do a character matching for you. So once I change this variable using the mutate function, so I write over the region variable so that my levels can be ordered in this way, the plot is basically, the bars are now ordered in that same order. So I don't have to do anything additional while I'm plotting my, when I'm making my visualization, because I've already re-leveled the categorical variable. What else we might do? We might clean up the labels. So let's go back and take a look at this visualization one more time. Rest of South has these underscores. Scotland is not really spelled out. It's just Scot. But these probably have better labels that we can use. So in order to do that, I need to take a look at my categorical variable and say, whenever you see this particular character string, replace it with this instead. When we have these like, if you do see this, do that type of situation, one way we've addressed this in the past is using a case when function. Another way we can do is actually build up on the fact that we are working with a categorical, or in other words, a factor variable, and use a function from the forcats package again. this time factor recode, so FCT_recode, which again takes as its first argument the variable you want to recode, in this case region, and then takes as many arguments as you need, and these are going to be kind of named elements, if you will. On the left-hand side, we have what we want that character string to be presented as, so what the new factor level should be. And on the right-hand side, in quotation marks, we have what it should be as it appears in our data set. So it is structure-wise different than how case when works, but it is yet another way of working with categorical variables without having to write an extensive case when statement. So once we do this, our plot now looks something like this. The bars haven't changed, but how they're labeled have changed. Another thing we might want to do is to put long categories on the y-axis. So that Midland and Wales, for example, was long, and some of the other levels as well. So sometimes instead of writing out your categories like this, where your bars are next to each other, you might actually flip the bar chart around. This is especially useful if you have many bars, and also especially useful if you have potentially long enough labels that they might overlap without making your plot take up a giant space in your plotting area or in your document. How do we go about doing this? Hopefully this one is an easy one. We've simply changed the aesthetic mapping. So before we were mapping region to X, and now we're mapping it to Y. We might then want to reverse the order of levels. So let me go back one more time. We went through all that trouble to reorder our levels, right, in the same order that YouGov had presented them, and also relabeling them to again match their presentation. But now that I have moved that region variable to the y-axis, if you think about how the y-axis works, if we have numerical data, we're going to start with the smaller one, so the beginning at the bottom, and then go up. And similarly, what R is doing here is placing the levels of this categorical variable in the same way. So the first one comes at the bottom, and then we go up. But that doesn't look really right for our purposes in terms of saying we want the categories to match how they were presented, the order to match how they were presented on YouGov. So the human eye wants to look at that and start reading from the top to the bottom, because we're not looking at a numerical variable, but a categorical variable instead. Now we could do another read level to reorder these things, but I'll teach you one other way of doing that, since what we're trying to do is not re-level to move everything around, but instead just to reverse the order of the levels. I can actually use a function called factor rev, so FCT_rev, which will basically do a reordering, but in doing so in a way where you're basically flipping the order of the levels. So I've simply wrapped my region variable around this. Now I've shown you two ways of using these forcats functions. One was within a mutate statement, so we overwrite what's in the data, and then next time we call the data frame called Brexit, we actually get to benefit from the fact that we had already done some of this work in terms of releveling or recoding. Or in some of the examples so far, I've placed the function from the forcats package directly into my aesthetic mapping. Which one is right? Well, let me put it this way, neither of them are wrong. It really depends on what you're going to do next. If it's a quick fix in your visualization, and especially if you don't want that fix to alter your data, then you might want to handle it this way. If whatever change you're making in terms of releveling or recoding is something you want to keep consistent for the remainder of your analysis, say for this particular visualization that you're making, but maybe for other visualizations you might make with the same data set or other analyses that you might implement with it, in that case, you're probably going to want to overwrite your data set. So use these forcat statements within a mutate function, overwrite your data set so that you can benefit from the results of that downstream in your analysis. So neither of them is wrong. Depending on your motive, one of them might be a better approach than the other in order for you to have to not repeat yourself over and over. Now that we've changed our plot a little bit, let's clean up our labels again. So the way we're doing that, once again, is using the labs function in ggplot to give a label for the x and the y axes. So let's go back to the plot and take a look at this. On the x-axis, we have the count, and on the y-axis, we have the regions. Do we really need to label the y-axis here as region? Is it obvious that things like London and rest of South and Midland and Wales and North and Scotland are regions or not within Great Britain? Really, the answer to this question depends on who your audience is. If your audience is people from the UK or from Great Britain in general, then perhaps the answer is, yeah, it is very obvious what that is. We perhaps don't need to label that. And similarly, we could be making the same argument about count. I mean, these are survey results. What else could those numbers be? But the answer to this question about is it obvious should not be answered in a way as, is it obvious to you, the plot maker who already knows a lot about this data set? But you want to be thinking about, who is my audience? Do I have a kind of a local audience for whom these regions would make a lot of sense and don't need to be labeled as region one more time? Or do I have perhaps an international audience who may not necessarily know that within Great Britain we tend to make a distinction between these regions, or that we might expect that the opinion on the issue of Brexit or many other matters may or may not differ between these regions? So you want to be thinking about your audience, and you want to be labeling your plots, your axes, accordingly. Sometimes the answer is very clear. Say you have some data that happens to have particular units attached to them. For example, we've looked at some fuel efficiency data previously. Are we talking about kilometers, or are we talking about miles? You definitely want to label this sort of stuff. We can't ever assume that it would be obvious to your audience. But when we're talking about something like this, where we're looking at geographic regions and you might think, well, this should be obvious, you just simply want to ask yourself the question, obvious to whom? And is that an assumption you can easily make or not in terms of who is going to be the audience of your plot? The next principle was to pick a purpose. So let's take a look at this. We're now bringing the two variables we've looked at together, opinion on Brexit and the region. And we've made a segmented bar plot because that's probably the most common way you can bring two categorical variables into a visualization. And the way we make this segmented bar plot, remember, is on the y-axis, we put our region and we want to fill the bars with opinion. Now, why didn't I do it the other way around? The question that the purpose of this visualization is to answer the question, do opinions on Brexit vary across regions? So I want to first partition my data in terms of the regions, and then within each region, I want to look to see say what percent or how many people said wrong or right or don't know, and compare that across. So since the first slicing of my data needs to be by region, we can also in dplyr terms think about this as when we're grouping, we want to group by region first and then count how many of each opinion within each region. We want to put that on the axis and fill with the other one. We can start gleaning some information from this visualization, but sometimes segmented bar plots can be hard to read. What do we do then? One way that we can do more is by using faceting. So here, instead of doing the segmenting, I've faceted the data by region, or actually in addition to doing the fill, so the colors stay there, I have also faceted by region. And I'm faceting by a single variable, so I chose to use facet wrap, but I wanted to place all of them next to each other, so those so that they could have one shared y-axis for the particular opinion. So I've specified that I want to put all of these facets into a single row with n row equals 1. So let's take a look at this. I have changed a few things here, as you can see from the previous graph. Now on the y-axis, I have my opinion, and the regions are across the facets along the x-axis. One argument was, or one of the principles was avoiding redundancy. Now you can see in the previous plot that we are both filling the colors in by region, but we are also faceting by region. So we have this, pretty nicely colorful visualization, but do we really need these colors? Do I really need London to be this pink and rest of South to be this green, so on and so forth? Or are facets enough? So let's take a look at this. It looks a little, duller, if you will, but it is avoiding redundancy. And the way we would create this visualization is simply by saying don't fill by region. Really, I think the way to think about avoiding redundancy is to say, is the redundancy helping you tell a story or not? So in this case, we have added a little bit of redundancy to our visualization. We have actually now colored by the particular opinion so that when we look at this visualization, our eye is drawn to all the blues at once, or all the greens at once, or all the pinks at once. So sometimes you might want this level of redundancy. So in this particular plot, the redundancy is in the fact that we're both using opinion for the Y aesthetic and also the fill aesthetic. So we're coloring the different levels of the Y axis in different colors. But we probably want to be a little bit selective with it still. So if we go back to this visualization that we just made, the colors indicate the various opinions that are already marked on our y-axis with wrong, right, and don't know. But then we also have a legend that ggplot gives to us automatically that basically tell us the same thing. Do I really need both of these things? Definitely not. So I might want to avoid that redundancy saying, I've already given you this information on the y-axis labels, don't give me the legend again. And the way we would do that is using the guides function in ggplot to turn off the guide, in other words, the legend. So specifically here, I'm saying in the guides, make the legend for fill false. Now, you might be thinking, why specifically fill? Why don't you just say turn off the legend overall? Why isn't it legend false, for example? But you can think of a situation where we fill with a certain color and color by a different color and maybe use shapes to indicate something else. So we could have different legends for each of these different aesthetics. So the guides function gives you the flexibility to turn some of them off and leave some of them on. So in this case, we want to turn off the fill legend, which happens to be our only one, but we need to specifically specify that that's the one we are turning off. And as a result, we get rid of the legend, and we now have just the distinction between wrong, right, and don't know based on the labeling on the y-axis. We probably also want to use some informative labels. So far our visualization did not have a title. So here I'm going to put as the title the survey question. So what is wrong, right, or don't know? Well, it is the answer to the question, was Britain right or wrong to vote to leave EU? Okay, that was the wording of the question from the survey, and we're basically placed exactly there. You should also note that I've gotten rid of the X and Y labels because I've decided I think the rest of this is obvious. I don't need Y to be labeled as opinion. It's very clear that it's the answer to the question wrong, right, or don't know. And I'm going to assume that given that this is a survey question, that the x-axis is clear as well, that we're talking about a number of people who said wrong, right, or don't know to this survey. So to turn off the labels, I'm basically using null, which is a special value in R, to say, okay, just basically get rid of the X and the Y label altogether for me. We can add a bit more information. This is a survey question. It's opinion about Brexit. Well, this opinion does not stay constant, right? Throughout time, this opinion might change. In fact, we might assume that this year, in 2020, maybe the opinion is even more different given everything else that's happening in the world. The country didn't really know that there was going to be a global pandemic when this vote happened. Did people's opinions change? It may have. So we want to make sure that it's very clear from our visualization that that sort of information is reflected. So we might use, for example, the subtitle field in our labeling to say these are coming from YouGov survey results, and here is when the opinion was collected. Another Another thing we might want to add is a caption, right? So the caption here is basically leading us to a URL where this data, the raw data, can be found. So the raw data is in a PDF file if you go to this URL and presented as the survey results. But let's take a look at what this looks like on our plot. We can see that it is a very busy caption, a really, really long label that leads to this PDF. So what might we want to do? If you have a very messy URL, you might use something like a link shortener to change that. So here what I'm trying to present to you is that this is the sort of information you want to make available with your visualization. You might be thinking, well, perhaps this comes within the context of a larger report where it's obvious this is where the data is coming from, in which case maybe you can avoid that information. But if this visualization is to stand alone on its own, then you definitely want to have this sort of this is where the data comes from type of information on there. And to make it easier for your audience to find it, you might want to put a direct link to it. And if that makes your visualization very messy, we'll just use any other method you would use to shorten a link and place that on there as well. So this is not necessarily visualization best practice, but in general, information communication best practice that's applied in the context of a data visualization. We might also want to fix up these facet labels. So let's go back to our plot where we feel like we're making lots of progress to something better than what we started with. But look at this Midlands and Wales. I mean, they're really like kind of scrunched together and we can't actually read the entire facet label. So we can actually ask ggplot to reformat the facet labels so that we have these like line breaks in there and everything can be a little bit more legible. And the way we would go about doing this is in the facet wrap function, there's an argument called labeler. So it allows you to customize how the labels are being made. And in this case, we're using a function called label wrap gen, which gives us a width. So the width, you can think about it as the number of characters. How did I come up with the number 12? 1, I counted characters, and number 2, I tried some stuff out. So whenever you're doing this sort of customization to your plots, you might want to, try out a number. And then if that's not good enough, try out a different number. We've talked previously about, for example, setting the size of your figures, the widths or heights of your figures. Again, you might want to try something, and if that's not good enough, you might want to change it. So here the takeaway message is that facet wrap, in addition to being able to in addition to allowing you to facet by a variable and also to customize how many rows or columns you want the facets to be placed in, we also can give it additional arguments that allow us to customize how our facets are displayed to our audience. Selecting meaningful colors. So far, we were working with the rainbow colors that ggplot2 has by default. So the blue, green, and this pinkish red are the default first 3 colors in the ggplot2 color scale. We said that we had a good reason for coloring the various opinions the same way across the facets, but are these the right colors, these defaults? These rainbow colors are not always the right choice. We might think about, well, wrong, red, right, green is like not a bad mapping. So we might use just standard red and green colors. I don't think this looks great, so we're gonna say a bit more about that in a second. That's a really, really jarring green and a really jarring red we have on the plot. And importantly, not every member of your audience might be able to distinguish between those 2 colors. So you might want to think about things like color blindness when you're thinking about coloring your plots. So usually choosing red and green to represent diverging kind of levels is not a good idea because some members of your audience may not be able to actually see the difference between these 2. Let's take a look at the code for getting this done, and then we're going to say a little bit more about how we might improve upon that code for better display. So we are manually choosing colors for our fill aesthetic. right? So the way we would go about doing that is using a function called scale fill manual. So scale, it's because it's about the color scale. So whenever we're basically manipulating how certain aesthetics are displayed, the functions we use generally start with scale underscore, and then it's the name of the aesthetic, in this case fill. And then we've seen previously, for example, things like scale fill viridis to use a particular preset color scale. In this case, I don't want to use one of the preset ones. I actually just want to give the colors, specify the colors myself. So I'm going to say scale fill manual. The argument that I'm going to play with is values. So these are the values of the colors. And I can give it a named vector. So a vector, because it's in the C function that is constructed basically by concatenating the three elements. A named vector means that each of the elements, so in this case, things like red, green, and gray, are actually named as well. And the way we're naming them is as the category labels show up, exactly as they show up in our data set. So wrong, but also wrong with a capital W, so that that character matching can be done. So what this is doing is saying whenever you see wrong, fill that in with red. Whenever you see right, fill that in with green. And then for don't know, fill that in with gray, since that's like gray perhaps is like a more muted color. Now, how does R know that red and green, these character strings, are actually meaningful? There are some preset colors in R, actually a really long list of them in R, and red and green happen to be two of those. So if we wanted these colors to be red and green, but not those really jarring red and green colors that we saw here, we could actually change the character string to talk about a slightly different red and a slightly different green that might be preset. But for now, let's keep the basics and keep in mind that one, we can manually give ggplot two colors to plot with. And number two, when we want to do that, we use scale fill manual, or if it was a different aesthetic, something like scale color manual. Now, with these in mind, now let's think about how can I actually improve the colors that I chose. But I'm going to keep in mind that I want somewhat diverging colors, right? And I want them to be something like something that might look a bit more alarming, if you will, in the red category for wrong, and something perhaps a little bit different or on the opposite scale for the right. One way of choosing colors is using this color brewer tool. So this is not an R specific tool, and there are actually R packages that implement exactly this, but I find this website really easy to use. So what we can do on this website at colorbrewer2.org is pick a particular color scheme. And then you can also pick whether the nature of your data is sequential, diverging, or qualitative. And you can pick number of data classes. So in this case, I had 3. So I picked 3. And you can also say, for example, you want colors that are colorblind safe or print friendly or photocopy safe. So in this case, I just checked colorblind safe. And then I clicked around with the various color schemes and decided this is a color scheme that I like. So here are 3 colors, something orangish, something whitish, and something bluish. And here are the hex codes for those colors. So each color can be identified by a hex code, and hex meaning that it has, it's an alphanumeric but 6-character length code. And so we have the hex color codes here, and we can actually add that directly into our ggplot. So over here, these were the hex codes. This was the hex code for the wrong, so the orange one. For the right, I chose to use the blue from that scale. And for the don't know, I decided to keep it the gray that I already had. So the only difference between what I'm showing you here and what we had previously is instead of using red and green, I tried to be a little bit more thoughtful about how I select those colors using the color brewer tool. And here's what the visualization looks like now. Sending the same message, but using less jarring colors, hopefully. Some of this is personal preference, and some of it is paying attention to things like not all members of your audience being able to see the distinction between those red and greens. We might also select a theme. So the default ggplot theme is this theme gray. So we have the gray kind of grid background for our data. I happen to like the minimal theme, where we have a white background and the grid lines are faint gray. But as you know, there are other themes in ggplot2 as well. And the way we implement the themes is we simply add another layer with the name of the theme that we want to implement. So you can try around for other themes as well. If you have a favorite one that you want to implement, that's the one you could choose. You might also want to think about whether this visualization will be displayed on screen or whether it will be printed, for example. All right, so we've basically taken this visualization. Initially, that was a single bar plot for just looking at the Brexit opinion and then looking at the regions. And then we put these two things together to say something about how the opinion across regions vary. In fact, if we go back to this final plot that we made, what are some things we can say about this data set? For example, the highest counts of responses, first of all, came from rest of South, and then from North, then Midland and Wales, it seems like, then London, then Scotland. And I think that makes sense in terms of the populations of these various regions. If we take a look to see how the various bars compare to each other, for example, when we take a look at the rest of South region, the lengths of the bars for wrong and right, so the orange and the blue, are very close to each other. It seems like the opinion is quite divided in terms of whether it was the decision to leave the EU was the right or the wrong thing. But when we look at a region like Scotland, for example, we're seeing a huge divergence between the right and the wrong, with a lot more people within that region saying wrong compared to right. In the north, those numbers are almost equal. And then in London, we're seeing a pattern slightly similar to that in Scotland. Again, opinions for wrong, saying that more likely to say that that was the wrong decision. So London and Scotland seem going a certain way, and then rest of South, Midlands, and Wales, where the population numbers are higher for in terms of, or at least the sample numbers for this are higher, we're seeing a slightly different opinion. So this is one story we can tell with these data and with the particular data visualization that we chose to make. In the next application exercise that I'd recommend you go to after you wrap up this video, we're asking you to make 3 changes to this visualization. So start with the last one that we had, and then make 3 changes to do things like comparing proportions, as opposed to comparing sample sizes, basically, or comparing counts that are very that are very much based on the sample sizes where the data was collected from, and then see if we're seeing a slightly different story, or if by restructuring our visualization slightly differently, we're able to get our point across a little bit better or not.